Good morning. Very good morning, everyone. Yeah, Shravan, Nagalakshmi, Sunita, and 4 others. Lakshmi, Sudharani, Vikram. Good morning, everyone. Very good morning, all of you. How are you all? Everyone, how are you? Everyone, how are you? Right. All of you had your tea, coffee, hot water, juice, breakfast, everything over? Breakfast, tea, coffee, hot water over or not over? Everyone. Fine? Okay. Very good. Very good. Right. So here we'll be continuing which one? This with our first topic, right? What is that you can say? Materials and workmanship, na? Yes or no? That materials and this workmanship will be continuing. Umang, good morning. Yeah. So up to which one we have discussed right yesterday? That which material we have started if you just remember? Which material we have started if you just remember? Yeah. Satvir, yeah, Ram, sir always say. Okay, Ram, right. So here yesterday which one we have seen if you just remember? Yesterday which one we have seen if you just remember all of you? Cement and aggregate just we have started, na? So no, aggregate just we have started it because some people were feeling difficulty. So we'll be just discussing about this aggregate again, okay? So we'll discuss about these aggregates again, you can say, okay? We'll discuss about which one these aggregates again if you just observe, right? Now here anyone having any doubts in our yesterday's discussions? Anyone having any doubts anywhere? Yeah, Nirmala, good morning. Any doubts anyone having? Right. Any doubts anywhere? Yes, Shruti, good morning. So if no doubts, we'll proceed further to our discussions, all of you. Right. If doubts are there, we'll just try to discuss those doubts, everyone. Okay. Right. So this is a quick revision of concepts and PYQs and concept through questions also, right, of RCC materials and specifications part 2, right? I told you, right? So some 3-4 lectures we'll be taking on this materials and workmanship only, right? Today we'll be entering into the main, or tomorrow we'll enter it reinforcement and concrete, right? All of you, welcome to Unacademy. Let's crack it, right? So everyone is ready to crack, all of you? Yeah, starting, don't worry. Everyone is ready to crack, all of you? Right. All of you ready to crack or not? Yes, get ready to crack, all of you. Right. So here, this is my profile. You can follow me at which, and this is the referral code you have to use, right? What is the referral code you have to use? RP Civil is the referral code you have to use, everyone. And now these are toppers from Unacademy in the SSC JE and State AE category into 2022, right? So next time I want all of you to get your photo and a name displayed here, okay? So now this is Samarth batch for this SSC JE and State AE courses is started in English, right? Especially in English is started now. And what is that a referral code you have to use, right? When you are going for this, RP Civil is the referral code you have to use, right? Now this is a fee structure, you can say. What is the referral code you have to use always, right? RP Civil you have to use, and you recommend the same to others also, right? 1 year is the most ideal one, you can say. So this so that what will happen? So your syllabus can be completed more than one time, so that you'll be having the revision also easily. And this is the latest batch started on which one? This is July 31st. Okay, myself has started surveying at 5:30 p.m. every day. We are doing. RP Civil is the code you have to use, right? And this is regarding the course, right? SSC JE State AE examinations, right? Now coming to this, right? These are all the subjects, right? These are all the subjects will be taken by me, and these are all the subjects taken by KP sir, okay? In English only, right? These are the major changes you know already, right? AEI vacancy is also available, you know, all of you. So this is a batch regarding that AEI, you can say, but this is only the recording batch, you can say, right? Now complete course on this surveying plus course we are doing now, is or no? 5:30 p.m. to 7:30 p.m. Monday to Saturday it will be ongoing, right? Free course on this quick concepts and PYQs of this RCC and PSC, right? We'll be doing every day. That is also Monday to Saturday we'll be doing, right? Every day we'll be having the classes, right? 8:30 am to 9:30 am, right? So don't miss this. This is part 2 we are having. And yesterday if you just observe, right, regarding what? Regarding the cement. So shall we solve some more questions also? We'll just solve few more questions also. First I'll be giving the poll. Right. Select the answer for this sixth question, everyone. Sunita, Satish, Naglakshmi, Sudharani. Answered correctly. Rajpreet. Good morning. Right. So 100% correct answer, right? What is that? You can say if you just observe, everyone. So what is that we are selecting, right? Yes, from YouTube, Nirmala also answered correctly. Right, Tajamal, good morning. For testing of this compressive strength and tensile strength of this cement, right? For testing of this cement, right? What is it? Yeah, Satvir also answered correctly. Cement mortar is made by mixing the cement and standard sand in the proportion of, right? This is 1:3 proportion we are going for, right? 1:3 proportion we are going for, right? So seventh question shall I go for? I'll be going for this seventh question, everyone. It's a numerical type, right? 60 seconds, okay, 75 seconds I am giving. Surya Narayana, good morning. Yeah, Putin Baba, good morning. You bring Zelensky Baba also here. Shruti answered correctly. The seventh question we are doing the poll now. Supriya, Surya Narayana, Tajamal, good morning, everyone. Gopi, good morning. Only one person answered correctly till now. Arey yaar, what about the others? Why? Why nobody was answering? Good morning, Surya Narayana. Right. So here, the number of cement bags required to produce 14 cubic meters of compacted concrete with the concrete mix having a cement factor as a 7, right? So yeah, Satvir said yeah. Okay, we'll check it, right? What is that cement factor? How many of you are having idea about this? This is also PYQ question only, right? Maharashtra Water Resource Department question, right? So cement factor, right? What is that cement factor? You can say cement factor is nothing but your number of bags, right? So number of this cement bags required per what? Number of this cement bags required per which one? You can say required per meter cube of concrete, right? Per meter cube of which one? This is concrete, right? Is now. So now got the idea how to solve this? So for 1 meter cube, how much it will be? For 1 meter cube, it is 7 bags required, right? Because it is a factor, cement factor comes to be 7. For 1 meter cube, it is 7 cement bags. And for this 14 meter cube, how much it comes to be, everyone? For this 14 meter cube, how much it comes to be? Dheeraj Singh, namaste. For 14 meter cube, कितना, how much it will be? कितना bags होता है? 1 मीटर क्यूब के लिए 7 bags चाहिए. 14 मीटर क्यूब के लिए कितना bags चाहिए? For 14 meter cube, how many bags we want? So that is your 14 into that is 7 na? 14 into 7 means 98, is na? So 98 number of these bags are required, right, everyone, right? Is it clear? Option C will be the correct answer, or not? Option C will be the correct answer, right? Like that. Shall we proceed further, everyone? No, actually, yeah. This is not, there is nothing here, right? Okay. 98 bags. One second. So whenever you are going for these aggregates, right, what is it? Next one will be having, if you just observe, next one will be aggregates will be having, right? So next material will be aggregates. Okay, which class it is? class 5.3, right? I am giving which one, this class numbers of this IS 486 2000 also, right? So that you will be getting some idea, right? So aggregates, right? Generally these aggregates, if you just observe, right, where you are providing these aggregates, right? This is your main member, is na? This is your main member, let us say, right, beam, if you just observe. And what is this, right? These are your main reinforcement bars, na? These are your which one? These are main reinforcement bars, you can say, if you just observe, right? Main reinforcement bars are like this, right? And now tell me, from the, yeah, Vignesh, good morning. From the center of this main reinforcement, right? From the center of this main reinforcement to this bottom, right? What it is called as, you can say, this is called as your effective cover. Is now effective cover, right? Everyone is clear? What is the meaning of this effective cover? You understood? From the center of this main reinforcement, right? This is our main reinforcement है ना? Main reinforcement बोलो तो क्या? ये main reinforcement क्या है? That is which is mainly resisting that bending, na? Yes or no? Which is mainly resisting that bending, you can say, right? And after that, what is that you are having is, you will be having the stirrups also like this, na, everyone? You will be having the stirrups also like this, or not all of you, right? You will be having the stirrups also like this, you can say. So whenever you are having the stirrups also like this, right? Just for an example, right? The stirrups are provided in this manner, just for an example, right? And now, from where to where, if you just observe, from this bottommost reinforcement surface to this bottom point, this is called as your which one? What is that name you are having? That is your nominal cover or this clear cover, na? Nominal cover or this clear cover, right? Is it clear, everyone? The difference between this nominal cover and this clear cover, everyone? Sorry, nominal cover and this effective cover. So difference समझ में आया है क्या नहीं? Effective cover और nominal cover के बीच में. The difference between this nominal cover and effective cover is clear, everyone? All of you. Right? Clear? All of you. Now, sir, you have kept the heading as aggregates, but you are discussing about this reinforcement. Yeah, don't worry, it will come about that why I have discussed this. Right? No need to worry. Now, here, if you just observe these aggregates, generally what are the aggregates we have to take? This type of aggregates only we have to take it now. So in general, which type of aggregates we have to take? That aggregates will be made up of which material, all of you? Generally that aggregate is of which one? Which material I am asking? Granite, na? Generally that aggregate is of which one? This granite material we have to use it or not? Generally by default, if nothing is mentioned at that aggregate, coarse aggregate, we have to use which one? Coarse aggregate, right? Coarse aggregate, right? Coarse aggregate must be made up of this granite or not? Coarse aggregate must be made up of this granite, right? Everyone. Suppose if granite is not available, and for these lightweight structures we can use other types of these aggregates also. What is that? Slag and crushed overburnt or tile, overburnt brick or tile for plain concrete members. So if reinforcement is not there, whenever that plain concrete members are there, we can use which one? Slag and crushed overburnt brick, right? Yeah, Bhunesh, good morning. Overburnt brick means, right, that brick is burnt like this, na? Yes or no? This is your overburnt brick, na? Yes or no? This example is that this right side figure is overburnt brick example or not, everyone? Yes, right? Next, what else will be using for plain concrete? Heavyweight aggregates or lightweight aggregates such as bloated clay aggregates and sintered fly ash aggregates, right? Bloated clay aggregates, right? These are your which one? These bloated clay aggregates, right? Have you seen these bloated clay aggregates? So these are your fly ash related aggregates, you can say, right? These are your burnt bricks, okay? Not bricks, okay? Yeah, burnt bricks, right? So either you can use this burnt bricks, right? Aggregates made up of this fly ash, right? You can use it mostly for which one? This is fine aggregate, this fly ash. And bloated clay aggregate, this is, you can use it as a coarse aggregate only, right? So this burnt bricks also we can use it as coarse aggregate or fine aggregate. We can use it as this coarse aggregate only mainly, na? Yes or no? Because large size particles coarse aggregate only we can use, right? So what is that bloated clay aggregates? If you just observe, have you observed what is it? What is it? Have you observed? These are which one? These are the clay balls, right? These are the clay balls heated, right? These are the clay balls heated, you can say, right? Or expanded, right? So the clay balls heated, upon heating, right, what will happen? They will be expanding and they will be taking this shape, right? And they will be taking this color. That red color comes why? Inside that, if you just observe, black color is there, na? Generally that clay you will be having that black color, na? Mostly black cotton soil, that clay content will be very much higher, na? Is that no? So inside black will be there, outside that red color comes, right? How it will come? When you are heating it, that because of this fire only it comes into picture, na? Everyone, right? So like that. So here, but such aggregates, right? Whenever these aggregates are there, so these are made up of this clay and fly ash. They should not contain which one? They should not contain more than 0.5% of this sulfates, right? As SO3, right? They should not contain which one? This 5.5% as sulfate. More than 0.5% sulfates are present now, then that aggregate is preferred or that aggregate is rejected? Tell me. If sulfates are more than 0.5 percentage, that aggregates will be allowed or that aggregates will be rejected? That aggregates will be rejected, na? Is or no? Now, when else you can reject? And should not absorb more than 10% of water, right? 10% of their own mass of this water, right? So if water content present inside is water absorbed by this aggregate is more than 10% of this weight. Suppose that aggregate ball will be having which one? This 100 grams. Out of this 100 grams, if 15 grams is water, so can you accept this aggregate or can you reject this aggregate? Everyone, we have to accept this aggregate or we have to reject this aggregate? We have to reject this aggregate. Now, is it clear, everyone? Generally, what is the type of this aggregate we have to use? Granite we have to use. And also apart from granite, what we can use? Slag, crushed overburnt aggregates, overburnt brick or this overburnt tile we can use for plain concrete cement. And also bloated clay aggregates we can use. And also this fly ash type of aggregates we can use, right? We can use many types, you can say, right? So when to accept it, when to reject it, is clear, everyone? Is not? Those are class numbers. IS 486 class numbers I am giving as it is, right? These are IS 486 class numbers. Class 5.3 regarding aggregates, na? Omar. Those are IS 486 class numbers. Directly I have copied the statements from IS 486 and giving, right? Because IS 456 is only reference to us, right? Nothing else. Is not? Whenever you wanted to counter any solution or whatever it is. Okay, you are asking that 5.2.2. Where is it 5.2.2? Where is it 5.2.2? Here 5.2.2 is not there, na? You are asking about the previous one. 5.2.2, 5.3.2. Okay. Okay, this one. Heavyweight aggregates. So either heavyweight aggregates. These are heavyweight aggregates, or these granite aggregates are heavyweight aggregates or lightweight aggregates? Tell me. These granite aggregates are heavyweight aggregates or lightweight aggregates? Tell me, Omar. These granite aggregates are generally heavyweight aggregates only, no? Yes or no? Heavyweight, right? Or lightweight aggregates such as, right? What are these lightweight aggregates examples? Bloated clay aggregates and sintered fly ash aggregates, right? So this is fly ash aggregate and bloated clay aggregates, right? Heavyweight, either the mentioned granite type of this heavyweight aggregates or this bloated clay aggregate or fly ash type of which one? Fly ash type of which one? This lightweight aggregates. So they can be used, right? Yes or no? They can be used, right? They will be used, right? Anyone you can use, but containing which one? But containing which one? Regarding these aggregates, na? So either they are heavyweight aggregates or they are which one? These lightweight aggregates. This condition must be satisfied, right? Yes, no? What condition? Sulfates should not be greater than which one? The sulfate content should not be greater than 0.5% as SO3. Why? Because if SO3 is there, right, what it will do? SO3 plus this, yeah, Deepthi Ranjan, good morning, no problem. SO3 plus, right, SO3 plus this H2O, right, what it will become? H2SO4, no? So what is the H2SO4, you can say? What is the H2SO4, everyone? What is the H2SO4, all of you? What is the H2SO4? H2SO4 is nothing but your sulfuric acid, na? Yes or no? H2SO4 is nothing but your sulfuric acid or not? So whenever that sulfuric acid is present in that, right? Whenever that sulfuric acid is present in that, right? Is it okay or it is not okay, you can say? It is not acceptable, na? Yes or no? It is not acceptable or not? Yes, it is not acceptable, you can say, right? So here what is the meaning of this is sintered, if you just observe is, right? So here generally sintered fly ash aggregates, right? So you are having this fly ash in the fine format or coarse format, tell me. It is in the fine format or it is in the coarse format, tell me. It is in the very fine format, na? Yes or no? It is in the very fine format, you can say, right? It is in the very fine format, right? Suppose if you wanted to use it as a coarse aggregate, can you make it? You just make this fine aggregate into the balls by adding some binding material. We'll be making into the balls so that it will be used as a lightweight coarse aggregate. Okay, so is it clear? That is the meaning of this is sintered. Okay, fly ash directly as a fine aggregate, but a sintered, right? What is it? A sintered fly ash will be using. That is sintered fly ash, can we use it as this fine aggregate, or sintered fly ash will be used as coarse aggregate? Sintered fly ash will be used as a coarse aggregate, na? Yes or no? Maybe 36, good morning. Is it clear? Sintered fly ash as coarse aggregate, so fly ash directly as fine aggregate, right? Got it? Clear? That sintered meaning is clear, everyone? Right? Sintered meaning is clear? Is not? Right? Because that process of making this into balls, right? That process of making this powdered into these balls of larger size is called as your which one? Sintering. Okay, that process is called as your sintering, you can say. That process is called as which one? This is sintering, right? Okay, is it clear? So whenever you are applying this process, na, yes or no? Whenever you are applying this process, right, what is it you can say? It is called as your which one? It is called as your which one? What is it you can say? That is a sintered fly ash. Okay, is it clear? Why you are calling it as a sintered? Is not right? Yeah, Aparajit, clogging. Where is that clogging? Yeah, okay. Clogging means it is just a jam or obstruction created, right? Closing the way, right? That's what you can say. Where is that clogging? Okay, somewhere. Is it clear regarding this aggregates, everyone? The basic materials for these aggregates is clear, everyone? So if sulfates are more than 0.5%, don't accept them, and water content is also more than 10% of its weight, don't accept it, right? Like that. Is it clear? So now we are entering into which one? This is size of these aggregates. So before we enter into this size, so those who did not enroll for this, okay, those who did not enroll for this plus courses, you can just enroll for this course, all of you. Samarth the batch, this batch you can enroll for this. Those who did not enroll, once you enroll, tell me, I'll go back and wait. See, clogging means it will stuck up there. Jam ho jayega, right? Jam ho jayega means clogging, right? Clogging means jam ho jayega, right? Yes, na? Right? It will stuck up there. That is the meaning of clogging. Okay, simply. It will not move further. It will be obstructed. Its movement is restricted. That is what. Okay? That is clogging. Okay. This one you want me to wait, Shruti? Why clogging comes, I don't understand this one here. It is somewhere else, na? Done? Okay. Right. Clear? So now coming to this, right? What is that you can say? This is fourth one. This is fifth one, right? So now this is very, very important, you can say, right? So whenever you are going, you know what are the materials to be used for these aggregates, right? Yes, what are the materials to be used for aggregates, right? And now, what are the size of these aggregates? Can we use any size we want? No, no. So the nominal maximum size of this coarse aggregate in no case greater than 1/4 of this minimum thickness of this member, right? Yes, no. Suppose if you just observe this member, so what is the minimum thickness you consider? This is your width B you are having, and this is your which one? This depth, capital D, overall depth you are having, let us say, right? So that the size of this aggregate should be, that the size of this aggregate should not be greater than which one? That size of this aggregate should not be greater than this 1/4 of this B we have to take, or 1/4 of this D we have to take it. 1/4 of this B we have to take it now. 1/4 of this B we have to take, right? Greater than 1/4 of this minimum thickness, right? Which one is minimum thickness? B is the minimum thickness or D is the minimum thickness, right? B is the minimum thickness. Now why? Why? Because if aggregate size is very larger, right? Suppose you are having only one aggregate here, right? Or you are having only one aggregate here, right? Is it proper way of construction? When you are having only one aggregate here, so can you able to ensure proper bonding with other aggregates? There is a because of its heaviness, it may be subjected to separation. It may be, this itself will be causing additional load on the member na? This itself will be causing additional load on which one? These are other aggregates, and it will cause a crushing of this chota bacha aggregates na. So it is better the aggregate size should be comparable to the member size, or it should not be comparable. It should not be that much comparable, right? That's why it should be lesser than 1/4 of this minimum thickness, right? Is that clear, everyone? And for most of this work, 20 mm aggregate is suitable, right? In general, which size of this aggregate we are using? 20 mm size aggregates we are using, right? Where there is no restriction to flow of concrete into the section. So thickness or width, right? When anyone, right? Minimum thickness, right? Minimum thickness, right? Minimum dimension actually, right? Here you can say it as which one? This minimum dimension. Okay, 1/4 of this minimum dimension of this member you can say. Okay, it can be beam, or just I have given example for beam. Okay, if it is a slab, I have given an example of beam. Suppose if it is a slab, what is that you can say? That the thickness of this slab capital D is there na? So aggregate size should not be greater than which one? This 1/4 of this capital D you can say here for this. If you just observe, it is depending upon the type of the member. Okay, for a given member, either it is a beam, column, footing, whatever it is, slab, whatever it is a member, thinner dimension you take, minimum dimension or thinner dimension you take. So smallest dimension, and aggregate size should not be greater than which one? It should not be greater than which one? It should not be greater than this 1/4 of millimeter, 1/4 of that, right? What is that? 0.5 millimeter. Yeah, 0.15 meters is the thickness of which one? This is the thickness of which one? This slab you are having. Na? I did not get your question exactly, Shruti. Yeah, slab. Whatever it is the slab thickness you are providing, right? Whatever it is the slab thickness you are having now, the dimension should not be, right? That the dimension should not be 1/4. 150 by 4 is how much? What is that 150 by 4? Tell me. 1/4 of thickness means 150. If you are saying thickness, 150 by 4, what is that you can say? It comes to be 37.5, right? So what you can select? You have to select the size of this aggregate lesser than 37.5 only. You cannot select greater than 37.5 mm. Okay, got it? Not used. What is the meaning of this? You should not select more than 1/4 means can we use 40 millimeter? 40 millimeter comes more than 37.5 na? Can we select it or we cannot select it? It is allowed or it is not allowed? Tell me. It should not be more than 1/4 of the dimension. So if thickness of this slab is 150 millimeter, so what is that 1/4 of this 150? 37.5. So that size of this aggregate should never be greater than 37.5. So it is better you select very much lesser value than 37.5. So generally we'll take 20 millimeter only, right? For slabs. Yes, na? We don't go up to 30, 35 also. We'll go with the 20 only mostly. Okay? Then 37.5 itself is not allowed. 40 is absolutely not allowed. No, definitely. Yes, na? You have to be careful. Now, suppose when there is no restriction to the flow of concrete. So why we are restricting the size of these aggregates to this 1/4 of this minimum size and 20 millimeter? Why we are restricting? If you just observe, because if larger size aggregates are there na, if reinforcement kg is like this, and when larger size of this aggregate comes, they will struck up here. Okay, they will struck up here, right? So what will happen? When they will struck up here, right? When they will struck up here, so is it okay for the concrete will flow to the bottom, or only that cement mortar will go to the bottom? Only cement mortar will go to the bottom. Entire concrete will not move. Aggregates will struck up there. So it is good or it is not good sign? It is a good construction or it is a poor construction then? If it is moving like that, it is a poor construction. But in places where flow of concrete is not a problem, concrete of any dimension can flow easily, then we can go up to which one? This 40 millimeter or this larger size also will be used, right? If you go with this mass concreting structures, now this is example, right? For the mass concreting structures, right, you will be having this or not, everyone? For mass concreting structures, you will be having this or not, all of you? For mass concreting structures, you can use this 40 millimeter or larger size also, right? In concrete elements with thin sections, closely spaced reinforcement or small cover, consideration should be given to the use of 10 millimeter nominal maximum size, right? So in general, what is that we have to use 20 millimeter, but if there is no restriction to the in general we have to use 20 millimeter, and the size of this aggregate should not be greater than 1/4 of this minimum size of this member. And if there is no restriction for the flow of these aggregates, right, they can flow freely, means we can use which one, this 40 millimeter, and more than 40 millimeter also we can use. And suppose if the reinforcement is very close, reinforcement is very closely spaced, then 20 millimeter is also not possible. 20 millimeter aggregates also will not flow through this reinforcement cage. Then you have to go with which one, this 10 millimeter nominal size. Is that clear, everyone? When to use 20 millimeter, when to use 10, when to use 40, and clear, everyone? Right, when to use 1/4 of this size. Clear, everyone? Right. So shall I move to the next? Shall I move to the next, all of you? This is regarding the size of these aggregates, right? So this is regarding the size of this aggregates, right, in general. Okay, this is regarding the size of this aggregate in general, right? When to use 10 millimeter? Suppose if the reinforcement is very small, very nearby, thin concrete elements with thin section, right? So have you observed this chaja or this lintel or this one? Have you observed this lintel? They are very small size, na? Whenever these are very small size, that 20 millimeter size of aggregate also will not be suitable, right? If you place it, only entire aggregate will occupy that itself, is not? So in that case, what we need to do, if you just observe, in that case, what we need to do, it is better we have to use this 20 millimeter larger size aggregates, or it is better we have to use the smaller size aggregates? It is better we have to use the smaller size 10 millimeter aggregates, na? Is that no? Got it now? When very thin sections are there, we have to go like this. Got it? Right? Once it is clear, tell me. Once noted, I'll move forward. Okay, you note it later. Okay, you note it later. Those who can write fastly, you can write, no problem. But now, next, we said that more than 40 millimeter also we can use, but here there are usage of plums, right? These kind of aggregates are called as very bada large boulder size aggregates are called as your plums, you can say. Okay, these are called with which name? Plums. So plums with what? 160 millimeter or more size can be used, not more than 20% by volume of this concrete, right? So if you are using plums, they should be the plums means those aggregate particles only, that boulders only, in the 1 cubic meter of this concrete. Suppose if you take 1 cubic meter of concrete, in that what is the maximum volume of this plums can be? Up to which one? Maximum volume of this plums can be up to which one? Up to this 0.2 meter cube only, no? It should not be, plums volume should not be greater than this 0.2 meter cube. 20% of 1 meter cube is 0.2 only, no? Is it clear, everyone? The first statement. Everyone, the first statement is clear. For a given volume of this concrete, that plums volume should not be more than 20% of the concrete volume. Okay? Plum volume should not be more than concrete volume. They will be distributed evenly, and spacing should not be lesser than 150 millimeter, right? Say spacing, which spacing? This is a clear spacing, not center to center spacing. You have to be careful. Okay, clear spacing, right? So what is a clear spacing? So from this plum to this plum, right? So this one to this one, right? So from here to here, right? How much minimum we have to maintain? This should be greater than or equal to 150 millimeter, or should not be lesser than 150 millimeter. Na? Why? If they are very closed, can you expect bonding? When these plums are very closed, cement mortar placed in between will be very much lesser, and that may be insufficient enough to create bonding between them. So when it is insufficient to create the bonding, is it of any use, or it is of no use? You can say it is of no use, na? Yes or no? So plum refers to which one? Hard, clean, natural stone used in mass concrete of foundations, gravity dams, embankments, and other mass concrete works. Is that clear? What is the definition of plum? Hard, clean, natural stone. Hard, clean, natural stone of larger size is plum. Where it is used? Mass concreting activities, right? Like which one? Like this one, this one. Okay, is that clear regarding plumb, everyone? Everyone clear regarding the plumb? All of you. Yeah, tell me, Shruti. Shall I move on to the next? Shall I move to the next? Any doubts, anyone in this? Now, see, suppose this is very large size, this is very large size, but if you are providing only small spacing between them, the cement mortar will be placed here only, na? So with the small, how much amount of cement mortar will be placed with a small spacing? Small amount of cement mortar only you can keep it now. With a small amount of cement mortar, can you able to maintain full bonding between this plumb and this plumb? When you maintain sufficient spacing na, so sufficient amount of which one, this is cement mortar will be present, then it can create full bonding between these two plumbs, right? Is it clear now? Bonding will not be proper if the spacing is lesser, is na? Right. Shall I move? Shall I move to the next? Right. So now, along with the sizes, right, 20 millimeter in general. So if there is no restriction for flow, we can go for 40 or more than 40 millimeter also size of the aggregate. If there is a restriction, so if thin members are there and reinforcement cage is also, reinforcement bars also very closely spaced, then you can go up to 10 millimeter size only. Along with that, we have to ensure this one also. Those must be satisfied and these must be satisfied, right? The nominal size of this aggregate should not be greater than nominal cover minus 5 millimeter. Now it is a clear nominal cover. What is that nominal cover? Is not. Why? What is that nominal cover? Is that clear, everyone? Okay. Nominal cover means this is the cover you are having. If you just observe from here to here, if you just observe, let us say from here to here, if it is, let us say 40 millimeter. So the size of this aggregate should be how much? The size of this aggregate maximum dimension allowed is how much, you can say? The size of this aggregate should not be greater than this 35 millimeter. No? Is not? If the nominal cover is 40 millimeter, so the aggregate size should not be greater than this 35 millimeter. No? Nominal size of the aggregate should not be greater than which one? Nominal cover minus 5 millimeter. Right? Why this 5 millimeter minimum gap you have to maintain? If you do not maintain this 5 millimeter minimum gap, what will happen? So this aggregate will struck up there, na? It will clog or it will struck up there or not? It cannot move from one place to other place. It is advantage or it is disadvantage? When you are pouring the concrete, this aggregate will stuck up there. It will obstruct the movement of cement mortar and other materials also. So somewhere gaps will be created. Uniform spreading will not happen. So for that reason, some gap should be there for a free movement of these aggregate particles or not. How much gap? Minimum 5 millimeter gap must be there. Is that clear? First one? And it should not be greater than the clearance between the reinforcement bars minus 5 millimeter. Same reason. So reinforcement bars from this clear spacing between the reinforcement bar, right? This reinforcement bar end to this reinforcement bar end, let us say it is 37 millimeter. And what is the maximum size of this aggregate we have to allow? The maximum size of the aggregate we have to allow is 32 millimeter only. It should not be more than this 32 millimeter. Okay? Why? Same reason. If your aggregate will struck up there, where cement mortar will come? Cement mortar, if cement mortar will not come here, bonding with other particles will not be ensured. Yes, no? Right, like that you can say. Is it clear? First one? Nominal size of the aggregate should be, maximum size of the aggregate is nominal cover minus 5 millimeter or clearance, clear spacing between the reinforcement bars minus 5 millimeter. So here also, this is 37 millimeter. If you are having the spacing, then maximum size of this aggregate will be 32 millimeter only, like that. Vertical, horizontal both. Second one, coarse and fine aggregates should be batched separately. So the materials when you are taking when you are taking that coarse aggregate weight and fine aggregate weight of required values upon calculation of mixed design, they will be taken separately. Don't take the weight of coarse aggregate and fine aggregate together. Okay, you take the weight of coarse aggregate separately, weight of fine aggregate separately. Okay, like that. Are these points clear, everyone? These points clear, all of you? Along with those specifications, these specifications also must be satisfied. First we have given 20 millimeter, 40 millimeter, 10 millimeter. Along with those specifications, these specifications also must be satisfied, right? You have to select the aggregate which is satisfying both that one and this one all. Clear? Shall I move? Shall I move forward? Next, what is the next material you are having? If you just observe, water, it is given in class 5.4, right? Water. So cement, coarse aggregate, fine aggregate, cement, coarse aggregate, fine aggregate we are having. Or before we enter into this fine aggregate, if you just observe, whenever you are selecting this fine aggregate, how to select this fine aggregate? Generally, which one is preferred? River sand is preferred. Na? Which one is preferred? River sand is preferred mostly or not? River sand is preferred mostly, right? So here if you just observe, when you can call it as the fine aggregate and when you can call it as a coarse aggregate, if you just observe. When you can call it as the fine aggregate and when you can call it as a coarse aggregate, everyone. When you can call it as a fine aggregate and when you can call it as a coarse aggregate, everyone of you. Any condition to call it as a fine aggregate and coarse aggregate? Any condition to call it as a fine aggregate and coarse aggregate? Sieve size, right? Which size will be taken as your coarse aggregate and which size member will be taken as your fine aggregate? Anyone tell me? Which size member is taken as your coarse aggregate and which size member is taken as your fine aggregate, everyone? So greater than 4.75 meters, right? If it is greater than 4.75 meters, then it is called as which one? Then it is called as your which one? This coarse aggregate. If it is lesser than 4.75 millimeter, lesser than 4.75 millimeter, so this is fine aggregate. So greater than 4.75 millimeter, it is called as which one? This is a coarse aggregate. Is not like that? Yeah, Jerry. Good morning. Pranam. Right. Where is Tom? You bring Tom also. Only you are alone are coming. Why? Right. Here generally that is sand. This fine aggregate, right? Yeah, more than 4.75 coarse aggregate. Yes. So this is sand will be taken. Which one? River sand is preferred mostly. So it is a zone 2 sand. So in your building materials, will be studying all these things. Right. Here RCC point of view, this point is only required. Right. Zone 2 as per which one? Zone 2 sand as per which one? This IS 383. Which code? IS 383 code will be defining this zone 2, zone 1, zone 3 like that. Yes or no? So we have to do the sieve size analysis. After doing the sieve size analysis, right, grain size distribution, we can identify whether it is which zone. Okay, right. There is a procedure mentioned in that. Right. Don't worry. Those things will be studying in building materials, not here. Okay. Just what is that sand required for concrete? That only we'll study here. Right. Zone 2 is preferable and river sand is preferable. IS as per IS 383. Okay. Shall we move to the next? Next element, water. Previous slide, this one. 7th slide. Right. Okay. Right. This is the 9th slide. Right. What is that next material you can say? Water. So coarse cement we have discussed. Right. Cement we have discussed and aggregates we have discussed. Right. Right. So here cement we have discussed, right? Cement we have discussed, right? So actually it is, if you just observe, fine, very finer material is there, never give up. Whenever very finer proportion of this material is very much higher, then what it will do is it will absorb more water. Okay. In that lesser than 4.75 only, but higher size materials are there, higher size particles are there, they will absorb less water, right? So based on that only they have given this which one? Zone 2 is preferable. It is having good conditions. It is not absorbing more water. It is not neither absorbing more nor absorbing less, insufficient also, right? Like that. So water should be clean when you are using it in the concrete or not? Yes. It should be free from injurious materials like oils, acids, alkalis, salts, sugar and organic materials and other deleterious material, right? What is the meaning of this deleterious materials? You can say hazardous, okay, hazardous or hazardous, right? Hazardous material, so whenever it is a hazardous material, we have to use it or we should not use it? We should not use it, yes or no? So whenever that water cement ratio, water by cement ratio, low water cement ratio like this, here high water cement ratio like this, you will be having the particles, right? So low water cement ratio means water cement ratio is low means water is lesser and cement is higher na. What is the meaning of this low water cement ratio? Comparatively water is of lesser quantity and cement is of higher quantity na. So then in that case, when cement is of higher quantity, what will happen? Low voids, low porosity will be there na. Low porosity, so porosity will be lesser, right? Porosity gaps created will be lesser, right? Strong and durable concrete, that will be okay. And if you just observe high water cement ratio, very high water cement ratio, right, what happens? High porosity means it will result in which one? This weak concrete. Now why it is weak concrete? When cement particles are very much far away, more gaps are created. When more gaps are created, can you ensure full bonding between the cement particles exactly? Full holding by the cement particles exactly? No. So now you understand what is the reason, main reason for water cement ratio is lesser means more strength, water cement ratio is higher means less strength, is not? So based on this only, high strength concrete, lesser water cement ratio, low strength, medium strength concrete, more water cement ratio we are selecting. Is not? Do you remember that? So don't worry, in the concrete material we will see this. For which grade, what is the maximum water cement ratio we have to select. Strength is inversely proportional to what? Water cement ratio. Okay, this is the conclusion of this diagram, you can say. Is it clear everyone? Right. So now the water should be satisfying this water cement ratio conditions na? Water should be satisfying that water cement ratio conditions, definitely or not? Water should be satisfying this water cement ratio conditions, definitely. Okay, note it and tell me. Note it and tell me. Note and tell me everyone. Done everyone? Srikar, good morning. Shall I move on to the next? Right. This is strength, right? Now these is specifications you have to remember definitely, right? These is specifications you have to remember definitely, right? So permissible limits of this solids are given in the table 1 of IS 46 as per class 5.4. So this is water class 5.4 only na. So now if you just observe, there are previous questions from this also in state examinations, SSC JE examinations. Okay, don't miss this. Whenever it is an organic material, what is the corresponding code we have to test as per this code IS 3025. But what is the maximum limit, permissible limit of this organic material allowed? 200 ppm or 200 milligrams per liter na? Is or no? Milligrams per liter is nothing but your ppm only, no? Is or no? If you just observe this milligrams per liter, so density of water, mass density of water is which one? This mass density of water is only 1 gram per cc, you can say. Then if you just observe what it comes to be, this is 1000 milligrams, 1000 milliliters it comes to be na. So 10 power 6. 10 power 6 is nothing but 1 million. Okay. ppm, parts per million, or milligrams per liter, both are same or not? mg per L is nothing but your ppm, parts per million. Okay. It's na. You might have studied in your environmental chemistry lab and all these places na. Milligram per liter is nothing but your parts per million. Okay. Now next, what are the dimensions, what are the inorganic materials allowed, limits allowed? Organic means it is decomposable or non-decomposable, you can say. Organic means it is decomposable or non-decomposable. Organic means it will decompose, is na? So that biological oxygen demand also will be calculating based on this organic material present only na. Environmental engineering, is na? Biological oxygen demand, but based that will represent the organic material contribution na. So no, presence or whatever it is. Inorganic material also it will be tested as per the same code IS 3025. What is the maximum limit allowed? This is 3000 milligrams per liter, right? 3000 milligrams per liter. Okay. Now Why it can be allowed higher value than organic if you just observe? Why higher value is allowed in case of this organic if you just observe? Sorry, inorganic. Because organic will be more dangerous, creating the diseases and everything, or inorganic is more dangerous. Whenever organic material is present, some bacteria and all other materials will come and microorganisms will come and stay on that, and they will extend their population. And suppose if you are sitting on the wall, you are just leaning on the wall, and there just beside your wall, what happens, you can see in that water used for this concrete construction for this wall, or water used for cement mortar in that brick wall construction, that is having which one is more organic material, the bacteria formation and this fungus formation, everything will be there, na? That will affect the structure definitely, na? And that will cause diseases also, na? Yes or no? So it is very dangerous to have more organic material. That's why organic material is lesser limit. Inorganic, okay, no problem, because it is non-reactive, na? Sulfates as SO3, sulfates as SO3, same IS 3025 part 24. So it is maximum limit is what, 400 milligrams per liter or 400 ppm. Chlorides as a Cl, right, IS 3025 part 32, 2000 milligrams per liter. For which one? For concrete not containing embedded steel. So for not containing embedded steel means it is a PCC, plain cement concrete, or reinforced cement concrete. Not containing embedded steel means it is plain cement concrete, na? Not containing embedded steel means it is plain cement concrete, right? And 500 milligrams per liter for reinforced concrete work, right? That is for which one? This RCC. Okay. Why? What you can understand from that? Whenever chlorides are higher, yeah, yes, rusting will happen definitely, right? Rusting will happen definitely, right? So to avoid this rusting only, right, what we need to do? To avoid this rusting only, what we have to do? We have to restrict the chloride content if it is RCC, right? Now understood why chloride content is restricted in case of RCC. Now suspended matter IS 3025 part 17, as per we have to test it, and its limit is 2000 milligrams per liter, right? So these are the limits of different materials allowed in the water, permissible limits of different materials allowed in the water. Okay, just note it and tell me everyone, or clear everyone, all of you? Organic material maximum 200 milligrams per liter, inorganic maximum 3000, sulfates maximum 400, and chlorides which one? If it is PCC 2000, and if it is RCC it will be up to 500 only. Yes, no? Suspended matter 2000. Clear? Shall I move on to the next? Right. So this is the last point regarding, okay, these are the points. Average compressive strength of this 150 millimeter cubes should not be lesser than the 90% of this same tested with the distilled water, right? Yes, no? If you wanted to use this water, distilled water is taken as a reference one. First you add the distilled water to the concrete, 150 millimeter cube of concrete of particular grade, right? Whatever the grade, M20, M30, M35, M40, for that grade you add distilled water of the required amount and you test it. You will be getting some strength. Okay, using the same proportion, same material. So instead of this distilled water, you use this water which you wanted to use for construction and check it. Using this water, the strength must be more than a 90% of this strength. So the strength obtained by this water should not be lesser than the 90% of the strength calculated using distilled water. Okay, it's not, then only you can accept it. And this water should not create which one? Initial setting time should not be lesser than 30 minutes, right? Then only you can use that water. If the initial setting time because of this water is greater than 30 minutes, can we use it? Sorry. If it is lesser than 30 minutes, can we use it or we should not use it? Should not be lesser than 30 minutes means it should be greater than or equal to 30 minutes, na? Should be greater than or equal to 30 minutes, right? If it is lesser than 30 minutes because of this water used, so can we use it or we cannot use it? See, what is that? Okay, I'll check it. Strength of this water used, strength obtained by this water used, okay, should be greater than or equal to which one? 0.9 times strength of this cube with which one? This distilled water. Okay, distilled water concrete cube. Okay, so that concrete is made up of which one? This distilled water, right? and now we are having a water body. With that water we are checking it, right? Yes, now can we use the distilled water for the entire construction? Can you able to bear that much cost? Distilled water is costly na, yes or no? Yeah, so water used for concrete, right? So is it clear everyone? So is it clear all of you? What is the meaning of this class 5.1 4.1.2? Right now, because of this water which we are using with our water resource available, so initial setting time, if it comes to be lesser than 30 minutes, we don't use that water. If initial setting time it gives more than 30 minutes, use it. Okay, yeah, comparing this whatever the water we are using with the distilled water value, okay, in terms of concrete cube test. Now more than plus or minus 30 minutes difference compared to that of distilled water is not allowed, and at the same time right, yeah, no, it should be greater than or equal to that one, right? It should, if it is lesser than 90% of this now, suppose using the distilled water, if you are getting this 40 MPa, using the distilled water if you are getting 40 MPa, and if you wanted to use this water and that water will give concrete strength, which one greater than or equal to which one, this 36 MPa, then only we can use that water now. If you with the distilled water you are getting, let us say 40 MPa for this M40 grade, just for an example. And if you wanted to check whether this water, we wanted to use this water or not, how can you check it? This water can be checked by which one? Use this water and prepare the concrete cube in the same manner as you have done with the distilled water. Just in place of distilled water, use this water, whatever the water you wanted to use from the water body available for you. Okay, that water, what you need to do? Test it. If you are getting lesser than 36 MPa na, then reject it. If you are getting more than or equal to 36 MPa na, then accept that water. Got it? So initial setting time should be more than or equal to 30 minutes, and also with respect to distilled water when you compare na, so initial setting time, right, IST of this distilled water and this IST of this testing water, right, IST of this normal water which you are testing, it should not be more than which one, this is 30 minutes. The difference obtained for the cement, the difference obtained with the cement for testing initial setting time na, the difference of initial setting times should not be more than 30 minutes, right? Then you accept it. Okay, if the difference is lesser than 30 minutes, you accept it, and initial setting time itself should be also greater than or equal to 30 minutes. Clear everyone? 5.4.1.3 everyone, when to use this water is clear all of you? Clear everyone, when to use this water all of you, right? Now other specifications of this water. See, initial setting time of this cement you are testing with distilled water na. Suppose if it comes to be which one, this is 30 minutes. Suppose if it comes to be 60 minutes. Initial setting time of this water, it comes to be which one, this 110 minutes. So this water is accepted or not accepted? 10, it should be more than 10 then, generally more than 10 is correct. Okay, whether we have to accept it or not. So that is giving which one is more than 30 minutes satisfied. Okay, so this water is giving whatever the water you wanted to use for a construction, so that is giving which one, this 110 millimeter, it is more than, right? So 110 millimeter is more than 30, 110 minutes is more than 30 minutes. Okay, more than 30 minutes, okay, that is fine, right? More than 30 minutes, okay, that is fine. But what is that you can say, difference 110 minus this is 60 is equal to more than 30 minutes, this is okay, this water is okay. But 110 minus 60, how much it comes to be? This is 50 na. So now this water can be accepted or not accepted? Initial setting time comes to be 110 minutes, okay, more than 30 minutes according to this first line, okay, that is fine. But according to the second line, it is satisfying the second line or it is not satisfying the second line? It is not satisfying the second line, it is not satisfying the second line. So can we accept it? No. When both are satisfied, then only accept that water for construction. Clear everyone? Okay, clear all of you? Then last specifications of this water, if you just observe, the pH of water should not be lesser than 6. Why? If a pH of water is lesser than 6, it will result in this acidic nature na. Whenever that acidic nature of this water is there, it will cause corrosion of this reinforcement easily na. So it should not be acidic, right? Lesser pH means acidic or which one? Basic nature. Acidic nature it will have or basic nature it will have. If pH is lesser, acidic nature na, Acidic nature means it will cause corrosion definitely, so you should not accept it. Don't use seawater for mixing and curing. Either for mixing with the concrete or for curing activity also don't use seawater. If unfavorable, use in PCC, no steel at all, with appropriate cement and precautions, right? There is no other go. You are having only seawater available. Then what we can use? We can use this seawater only in case of what? Only in case of this plain cement concrete. Why? Why not for RCC? Because that seawater means sodium chlorides will be there. Na? Sodium chloride. When these chlorides are there, these chlorides will create a rusting to this reinforcement definitely. Na? So to avoid that, this is seawater should be avoided, right? Is it clear everyone regarding the water? Aggregate and water specifications, everyone over? Aggregate and water. So tomorrow we'll discuss about which one. After solving the questions of water, we'll be discussing about which one, these mineral admixtures and chemical admixtures. After that we'll go for the concrete. Okay, with that materials will be over mostly. Okay, then loads, partial safety factor and all these things also we'll discuss. Clear everyone? So tomorrow we'll do the questions. Okay, tomorrow we'll do these questions, remaining questions on this water and aggregates. So I'll be closing the session. Thank you all of you.